Hello, we are Alex.
And Yasmin.
And in this video, we will be presenting the Snake video game implemented in a digital circuit. We built and simulated our circuit in Wired Panda, an open source software developed and maintained by students of Unifesp, the Federal University of São Paulo. Snake is a very simple game. The objective is to eat food pellets while avoiding collision with your body, that grows each time food is eaten. To start playing, press the reset button for a while and release. The game should initialize with an X in the corner, representing the next piece of food the snake should eat, and an 8 representing the snake's head. Zeros behind the snake represent the snake's trailing body. The head can be controlled with the W, A, S, and D buttons on the keyboard, signaling the direction the head should go next. Simply tapping one of the WASD keys will make the snake move in that direction until another direction is chosen. Trying to move the head into its body or the walls ends the game and resets the playing field.
To understand the underlying logic, first we should understand how the circuit works on a more conceptual level, analyzing the game state diagram. Each cell is like a Moore state machine. The possible states for a cell are air, body, food, or head, represented by the 2-bit binary numbers 00, 01, 10, and 11 respectively. The new state of a cell is determined by its previous state and its input, as you can see in the diagram. Air can only become a head if it receives a will-be head from a neighboring cell. The head can only become a body, and a body can become food or air depending on the size of the snake and on the was food eaten signal. When a cell turns into a body, it activates its own counter that will count up to the current size of the snake. When it reaches this size and no food has been eaten, the cell will become air or head. If it receives the was food eaten signal, it becomes food. Reset is a special signal that will turn all of the cells into air, except for the walls and the initial head and food. The reset is activated by the new game reset button, or if one of the body or wall cells receive a will-be head signal, meaning the snake collided with its own body or a wall. If one of the cells is food and receives a will-be head signal, meaning that the snake will eat, it sends a global was food eaten signal, implying the snake's size will increase and then a new food must be generated.
Now that this concept of how each snake cell works is known, we can look inside the circuit to see how the next state and outputs are calculated. Right off the bat, we can notice the internal counter that is used for controlling the body's lifespan. It only counts if the cell is a body, resetting if it becomes a head, air, or food. This counter sends a reach size limit signal when a body size is equal to the global snake size. Reaching the size limit, the circuit sends a signal determining if the next state can be air or food. It should become food if the last piece of food was recently eaten, or air otherwise. For determining if a cell must be a head, the circuit checks if there is an incoming will-be head signal and the current state of the snake. If the snake is air or the body that is about to become air, then the snake cell should become a head. If a cell is food, then a food eaten signal should be sent to represent the head eating the food, and the cell should also become a head. If the snake is already a body or a wall, then a reset signal is sent. If the cell is currently a head, we will send a will-be head signal to a neighboring cell according to the global snake direction, and a signal that the next state should be a body. A simple encoder is used to join all the next state signals. If no state signal is on, then we instead repeat the previous state, so food should continue food and air should continue air. Unless, of course, a reset input is on, then the circuit should reset to air, food, or head depending on the type of cell. A special type of cell, the wall, is a constant body cell, stripped from its state-changing functionalities, that sends a reset signal if a head is to collide with it. Now that we have our cells working, they can be used to generate the final circuit.
Beyond the snake cells and walls, the circuit must also contain a counter for the snake size and a form to send the directional input. The input directions are encoded and sent to a D latch, which is only enabled if a single direction is being pressed. The counter of the snake size is only incremented when the food has been eaten, with a delay to prevent collisions between the food being generated and the extra body cells. Finally, after all of the cells have been connected, LED cells are connected to the snake cell grid to convert the current snake state into a 7-segment LCD format. And there it is, the complete circuit.
Now we just reset and play. As you can see, when the snake eats, its body gets bigger. If it crashes with a wall or its own body, it dies and the game resets. The original idea was to make a 16 by 16 playing field, but for technical and practical reasons we decided that a 4 by 4 grid would suffice for a proof of concept. Well, I guess that's it.
Thanks for watching and see you next time.